Good afternoon. My name is Lee Johns, and I'm the VP of Product Management for Starboard Storage. Thanks for coming along to the presentation today. Starboard is a new storage vendor. I'd like to introduce us to you, but mostly in this presentation, I really want to talk about the benefits of next-generation storage architectures and how you can take advantage of those. I will talk about our architecture as illustrative of that new class of product. And of course, you want to make sure that you really understand the benefits and how you can employ this kind of technology today to really lower the cost of your IT and improve the performance of your applications. So, next slide. Starboard Storage Systems is the first purpose-built unified hybrid storage company. We deliver a platform that combines SAN and NAS. We deliver flash optimized performance acceleration in every single product that we sell. That enables us to deliver the performance of solid state at the economics of spinning disk. And we're a technical innovator. This product has been built over 3 years. It's a new grounds up storage operating system design, which is a block-based platform, but has alongside that a file-based capability. And we have strong executive leadership. Our CEO is Bill Chambers, who is the CEO of Left Hand Networks and founder, and a number of other folks within the company who are well-known industry veterans from companies like Compellent, Dell, HP, and LSI. Next slide. Our focus is on delivering customer value. And the way that we think of that is in a triumvirate of enabling you to drive higher performance for your applications and deliver that value to your business. Lower the cost of capacity, but make sure that you have scalable capacity so you can keep up with the growth demands that you have. And then drive efficiency in terms of both OPEX and CAPEX by enabling you to get more features and functions for your money, and of course make sure that the system is easy to administer and easy to support. Next slide. One example of a customer that we have, and I think this is an ultimate example of data retention, is the University of Arizona and their Large Binocular Telescope. It's one of the world's leading research organizations. They have the largest binocular telescope in the world, and they're looking back 2 billion miles, and so 2 billion light years in terms of actually collecting images. And those images, of course, are very precious. They do global research and analysis, and they store those images on a Starboard storage system. And because of the growth that they're seeing, they need a low cost of capacity in order to store that. But those images are precious. They need those images to be protected. They do that with our built-in replication, and they replicate to Tucson, 100 mile away. And in doing that, they also, of course, when they want to access these images, need great performance. And that great performance, when they need it for those applications, is driven by our solid-state acceleration tier. Now, as well as storing those images, this telescope is a shared project between some different universities. They have billing systems for time used on that platform that run on the storage. They have email systems. They have virtualization running on those platforms. So it really is a consolidation of a number of different workloads onto a single platform. And this is the power of a unified system like a Starboard system. One single operating system that can support NFS, CIFS, iSCSI, and Fiber Channel. Next slide. So let's take a look at some of the driving forces in the storage industry. Obviously, we're seeing huge data explosion. We're seeing convergence, and this really is driven by x86 architectures being powerful enough to run storage, and storage really becoming a workload on an x86 architecture. Everybody is using virtualization. Everybody wants to understand how to get to the cloud. What they mean by that varies greatly. We'll talk a little bit about that as we go through. But from a technology standpoint, solid state and flash have really started to change the equation in storage. People think that solid state and flash is really just about performance, but it's not really. It's also about making sure that you have very cost-effective capacity. And again, we'll cover this as we move on. Data protection is key. Every piece of data that we have today is important. It's critical to the organization. The most critical things to your organization are really your intellectual property, and that's generally carried in your people and your data. And we live in a world of immediacy. Everyone wants everything now, and so in that world, you've got to work on how to speed up the access to data when people actually want that data. You can't predict when they want it. You can't set up a policy for when they want it. You need to deliver it to them at the moment that they want it. Next slide. So what we hear from storage challenges of customers is that their architectures tend to be older. A lot of existing storage architectures were designed 20 years ago. They find that they end up with storage silos and vendor lock-in. They have poor utilization rates. A lot of times we hear the term Franken storage. This is really where people have taken multiple different storage platforms and tried to pull them together into some kind of coherent system. Maybe they've got NAS in front of SAN. What it means is that you end up with something that's actually complex to manage and to run. There's a lot of cost associated with storage, not purely in the capacity, but in how you actually manage that capacity. Expensive line item software, sometimes capacity-based licensing, hardware refreshes tend to be costly, hardware renewal and maintenance costs, warranty and maintenance costs tend to be high, and forklift upgrades can be very complex to manage as well. So we see all of this from our customers as they talk about their existing storage and what it is they're trying to solve. Next slide. Most customers have mixed workloads. They're not just running virtualization. They're not just running Microsoft applications. They're not just running file-based applications. They have all of those. And traditionally, in order to solve those applications and make sure that each of them is optimal for their company, they've built storage silos. They've got different storage, maybe for running file. They maybe have an iSCSI platform where they're running their virtualized apps, and then maybe a high performance fiber channel system that might be running some of their databases and other Microsoft applications. And this is an inefficient model because of the silos that it introduces, and it doesn't share resources across these different applications. Next slide. So we hear a lot that what customers are really looking for each of these applications is predictable performance. And what we see is that on average, and this has been from a number of different studies as well, that about 5% or sometimes less of people's application data is actually active at any one time. Problem is, you don't know which 5%. You have no idea what's going to be active today or tomorrow. You don't know whether a new marketing campaign is going to suddenly drive people to a particular application on your storage backend. And because you can't predict that, it makes it very difficult to manage your storage to that 5%. But of course, you are looking at those ongoing lower IT costs where you want to improve performance and capacity utilization, and you want to reduce power and cooling. So we'll talk about what you can do about this 5% of active data. Next slide. So a way to handle that 5% of active data is to look at hybrid storage. And hybrid storage is really storage that incorporates both SSD or flash and incorporates spinning media. And combining those enables you to drive maximum performance and efficiency from the resources that you have. Now, there's two approaches to that. One is from traditional vendors who are adding SSDs to aging architectures. Problem with that is that those aging architectures typically were not built to understand the benefits of SSD. They may be striping RAID constructs across those SSDs, reducing the utilization that you get out of those. And they're not able to efficiently leverage the SSD architecture because it's never always there. It's an add-on to the system. And then there are startup vendors, and we would class ourselves here, who are building SSD accelerated systems from the ground up. But typically, a lot of those vendors are really just looking at iSCSI. And iSCSI overall represents only about 15% of the market. So you have a lot of different workloads. You have potentially iSCSI and fiber channel in your environment. The largest growth of data is in unstructured data and in data that you probably want to manage from a file-based perspective. So being able to consolidate those is really key, we think, to hybrid storage. And that's what we call unified hybrid storage. And the benefit of that is when we get on to talk about the SSD caching, if you're using something like an SSD cache, it's really a performance utility for your applications. And that performance utility works better the more applications you're able to share it amongst. Because then you have the ability to optimize it for all of the applications that are lying underneath. If you have separated out silos of NAS and SAN, you're going to have to buy at least twice as much SSD to go handle those equations. So you really need to look at how can you consolidate, how can you make sure that you're going to get really active and predictable performance out of all of these different applications to drive down costs. Next slide. And so what we really do at Starboard is we virtualize your storage workloads, just like hypervisors virtualize your server workloads, where they're enabling you on a system to share a pool of memory, processor, and network resources. We're enabling your volumes and your shares, your NAS and your SAN workloads, your unstructured, your structured, your virtualized data, to share disk capacity, SSD cache performance, and bandwidth on the Starboard storage system. Next slide. So a unified hybrid storage system, from Starboard, can provide you with, as we talked about, the performance of solid state at spinning disk economics, the solid state tier that we provide for acceleration keeps active data in cache, it stores data at rest on hard disk drives, and there's no manual knowledge and policy tiering required to do that. You don't have to understand in depth your applications, because we're watching them as they're interacting with your users. We're watching those workloads, we're watching the I/O, and we're managing the applications not just based on how many times they get hit or how frequently or how recently they've been accessed. We're managing it based on what is the quality of that data. How important is that data? How long should that data be maintained within the cache to make sure that you get optimal performance from your system? And then at the back end, we're enabling you to have very cost-effective expansion with a mix and match of disk sizes in one single storage pool that takes away the complexity of RAID groups and scales to over 0.5 petabyte. Next slide. So that's all well and good. You've got performance, you've got low cost of capacity, but one of the other big costs in storage is how do you manage it? And how do you make sure that you have all the capabilities to manage that storage? And there, we provide an all-inclusive licensing model. So whether that's the configuration of your system and the provisioning, whether it's having thin provisioning, which is built in really to every volume, having snapshots, replication, solid state, acceleration, analytics, and phone home. All those things are built right in. You never have to license those. There's no capacity-based licensing. There's no line item pricing for software licensing, and there's no licensing for the new upgrades on that system as well. So very, very cost effective and all-inclusive, easy to understand and manage. Next slide. The system itself, the Starboard AC72 really is our flagship, is a storage device. And the storage device, as I said, contains hard disk drives and solid state drives for performance. And you can see that here. In a standard model, we may have 12 hard disk drives in a dynamic storage pool, and then we would have 3 solid state drives in an accelerator tier. There'd be a space for optional expansion of SSDs, and there would also be the ability to add more expansion shelves to add both spinning media or solid state, and eventually scale up to 576 terabytes. All the protocols are standard, and that's easy to manage across all of those different protocols on the system. So how does the tiering work? Well, the Starboard architecture, next slide, is called the MAST architecture, and that stands for Mixed Application Storage Tiering. And essentially what we do is we enable, firstly, writes to go to a dedicated mirrored SSD write cache. That means they have high availability and integrity because it's mirrored. If there are sequential writes, we'll bypass that write cache and we'll stream directly to disk. But ultimately, any writes that hit the write cache are then lazy written down to disk in background. And ultimately, we will flush them from that write cache when they become less relevant and the system has, a second to be idle and to flush that out. Also, our metadata is handled on that write cache, making things very fast. Because it's a multi-protocol system and can handle multiple workloads, we have a whole bunch of different types of workload on this system. So once that data is committed down to the hard disk drive, we're watching over that, and any chance we get, we're going to promote that data when it's hot or when it's an important piece of data to your spillover read cache. This is an augmentation of memory for cache. And that is essentially then holding a hot copy of your data. There's no impact to performance for doing that. There's no policy to set. You just get accelerated performance on demand when your application demands it. And underlying that, we have our dynamic storage pool. It takes away the complexities of managing traditional RAID groups. It supports multiple drive types and sizes. When you add capacity, that new capacity from those drives is available to all your shares and volumes in your system. Because of the architecture, it provides a very, very fast disk rebuild. It does not have to rebuild the whole disk like a traditional RAID controller. It just needs to rebuild data on the disk, and we never write zeros to those disks. So we are very, very fast in terms of recovery, and that helps you statistically in terms of how exposed you are to any kind of failure on the system, and gets you back into a very, very highly protected state. And we wide stripe data across many disks, and doing this obviously gives us as well the ability to lay out data in a performance orientated way and make sure we can truly drive performance from thin provisioned volumes. That's an extremely important element. Next slide. So because of that architecture, you can consolidate storage workloads. So let's think about file services, Microsoft apps, virtual servers, virtual desktops. Each of these has a very different characteristic. But whether you're optimizing for dollars per gig, dollars per IOP, whether you have a very adaptive application like VDI, where generally during the day it's a lot of random writes, but you may have boot or login storms that cause heavy reads, the system adapts to that. And because it has a separate read and write cache, it's able to optimize to the needs of those applications very, very simply. There's no need to try and understand within the system how much you're applying to each of those read and write based acceleration initiatives. And this allows you to consolidate and get predictable performance from your applications. Next slide. One such customer that we have is Digitex. They saw about a 20x performance increase versus their previous iSCSI SAN. And they're a hosting provider. They provide high performance hosting for their customers. And really the key to them was just the simplicity of Starboard storage apps in making sure that they could very, very easily set up and scale the system. Next slide. So one of the key elements of an architecture like this is that it changes the equation. Typically, you've probably thought of spindles as being key to performance. And typically, you've thought of 15K drives as being the key to driving performance for your most needy applications. But because of the solid-state cache, that paradigm starts to break. And if you look at internal jet stress testing versus some of the published numbers on the web, at Starboard we can deliver 80% more users on a jet stress environment. This is an exchange simulation with 80% fewer disks than some of our competitors. And the reason for that is because of that solid state capability, but not just the fact that we have it, because competitors have used that too within their models sometimes. It's the efficiency of how we use it. And that means that we can use 7200 RPM drives, get all the capacity that we need out of 12 drives, where it may take a competitor 64 drives, and they can't drive the same level of performance and the same level of mailbox users on that system. Now, what does that mean? Once you start to look at using, more drives, that adds complexity to the system. So let's take an example where we're using 15K drives in order to deliver a 36 terabyte raw system, or we're using 3 terabyte drives to do the same thing. And let's just assume at the moment that the performance is the same. In fact, I just showed you that we can even outperform with those 7200 RPM drives that other set of other solution. But let's assume that here it's the same. Even then, the key is you've got less drives. Less drives statistically will fail less often. Not only will they fail less often, in an architecture like this, they will rebuild themselves faster. Not only will they rebuild faster, there will also, because there's less drives, be less energy consumed. And in fact, just in a very simple calculation, just using that 60 drives versus 12 drives scenario, not counting anything else about the system, but just counting the energy used by drives, there's about a $6,000 difference just in the energy consumption for power and cooling over 3 years. Next slide. The other element, of course, that really I think hits a lot of people, and oftentimes after they've already purchased their system and they're in the midst of using it, is the licensing. You're a captive audience at that point. And if you want to be able to use some of the technologies, you have two choices. Either you don't use them, or you pay a license and you get a license to use things like tiering, replication, then provisioning, snapshots. At Starboard, everything is all-inclusive, and this is really something that makes a huge difference. It's not just about how much you're paying, it's about your propensity and ability to use these technologies. These technologies save you money and make you more efficient in many, many different ways. The fact that you're using them is much more important than necessarily the cost. But, of course, the fact that it's all-inclusive makes a huge difference. Remember, there's often a lot of hidden elements, as you look at traditional architectures that make up those final costs. Next slide. I mentioned the cost of, or the speed of recovery of disks. This plays into the cost of downtime. Of course, you really have to have high availability throughout the architecture, and we definitely provide that kind of fault tolerance that you would expect from an enterprise class product. But lost revenue is extremely costly, and there's a quick calculation here you can do if you want to go take that back and understand what the cost of downtime is to your organization. But because of the fast disk rebuild times that we have versus traditional RAID groups, that's going to make sure that you have statistically less downtime, and that's an extremely important issue for any customer. Next slide. And the other element, which is very different than some traditional architectures, is you save as you grow. Once you've installed a system that has solid state at the front end, you've paid up front for that acceleration across your applications, your ability to add more storage on the back end is based more on the cost of adding shelves to that system. And therefore, as you expand, your cost will actually come down in terms of cost per gigabyte. And that's a huge saving from a total cost of ownership perspective. If you're today using scale-out systems, that cost of capacity never changes. It's the same every time you buy a new node within a scale-out storage system. If you're using traditional architectures from the major manufacturers, the additional software licensing costs and other elements make sure that you do not get a real reduction in the cost as you go forward. But as you can see here, there's a lot of benefits to these new hybrid architectures that enable us to be able to drive that down. Next slide. And of course, because it truly is a unified system, it's not a gateway sitting in front of an array masked as a unified system. It's truly one operating system. You can eliminate cable management headaches. There's no Franken storage involved here. This is a single operating system on a single platform with a single management interface to manage all of your protocols and workloads, and to eliminate the need for you to have to proactively manage the performance for each of those workloads. That is done inherently within the architecture as we look at the I/O and make dynamic decisions. Next slide. So, one of the other aspects, I think, of making sure that you can really get the value out of a system is, of course, service and support. And one of the elements that we're pioneering too is the inclusion of a 3-year service and support capability warranty within your product. So the standard warranty that's included is a 3-year 24/7 next business day parts replacement warranty. And you can upgrade that to 7x24 4-hour response. You can upgrade to 5 years at the time of purchase. You can upgrade after your first 3 years and get yearly upgrades. But the most important thing is that with integration with Phone Home, we have a very, very proactive and powerful storage capability built right into the system. and included within the calculation of the cost of the system over time. So ultimately what that enables, next slide, is a huge difference in the total cost of ownership versus legacy unified storage platforms. And this is against unified storage platforms, not against if you are buying gateways in front of arrays, which is an even more costly and complex proposition. The fact of the matter is that even in cases where the hardware has come down considerably in price, all of these other costs drive up the cost of the traditional competitive systems. So you've got to make sure that as you think about, am I going to incorporate SSD? Do I want performance? How do I get cost of capacity on the back end? That you look at the architecture, you look at the licensing policies, and you make sure that overall that cost of ownership over 3 years you solidly understand. Next slide. And then, of course, we are not the only next generation hybrid storage vendor. There are very few who are unified and provide that consolidation, which is really necessary to get the best out of your solid state. But we are the first purpose-built unified hybrid storage vendor. We launched here early in 2012. Our master architecture is patented and really extremely efficient in terms of the way it does caching for all the workloads. The accelerator tier has a mirrored write cache, SSD write cache. That's extremely important too. A lot of alternative architectures do not commit to a mirrored write back cache of SSD within the architecture. And where that really comes into play is when you have heavy writes. Could be in your database app, could be because of a VDI workload, but that's a critical element to take a look at. It's easy to provision these apps with Starboard storage apps. The dynamic storage pool at the back end enables you to have very fast disk recovery, use any type of disks, and scale your system very simply. And the Starboard system scales to over 0.5 petabyte in a single system, so it's giving you plenty of headroom for your applications. So it's a very powerful architecture, and I encourage you to take a look at hybrid storage systems and sort of understand what is going to be right for you. Next slide. With any system, we're making sure that we do as much as we can to help you maintain and back up your data over time. We have space efficient, application consistent snapshots in the system. They take up no space, relatively little space in the system, because they are really just pointers to the data. Those can be replicated to another system, and you can use that for short-term backup. But ultimately, you really need to have a solid backup. And we partner with 3 very different and powerful backup vendors in Acronis, Veeam, and SEP, who are excellent in different areas for particular types of systems. As we're at a VTUG today, Acronis is more focused on both physical and virtual, and can provide a total backup solution across all of the workloads we've discussed. Veeam, incredible focus and great product around virtual machine backup for VMware and Hyper-V. And SEP provides unified backup, but is also very strong in the Citrix space. So these are key partners for us and enable us to make sure your data is protected. Next slide. The Starboard portfolio is pretty simple. 3 models. And you can see here the kind of scalability that we offer in those models. As you scale up, you get more expandability, and you get more standard cache within the product. So as you move up, you're going to be able to consolidate more applications, you're going to be able to scale more easily, you're going to be able to drive higher performance for those particular applications. But every single product identical in terms of the software that it offers, and you can see the list of the capabilities there on the right hand side. Next slide. So in summary, Starboard is the first purpose-built unified hybrid storage system. We combine solid-state performance and affordable capacity in a very unique dynamic storage pool to create an easy-to-manage environment that enables your applications to, on demand, and that demand placed is by the application use itself, to move between the right tiers of storage to offer you both the performance in terms of dollars per IOP and the capacity in terms of dollars per gig that you need, giving you predictable performance for consolidated applications and completely lowering the cost of ownership of storage over a 3-year period with built-in licensing and support, and the fact that we're really reducing and breaking this equation of spindles means performance. Yes, you can still add spindles and get performance, but there's a very new kid in town. That new kid is SSD, and SSD makes a huge difference to performance of most of your applications. Dedicated read and write, and with an architecture like this, you're able to completely transform how you think about storage and how you think about deploying your virtualized IT architectures. Next slide. With that, I'd like to say thank you. Thanks for coming, and I hope you enjoy the rest of the show, and look forward to speaking to you at another point in time. Thank you. Bye.